Now we're going to put it all together. We're going to use our in behavior and our zeros to figure out what this graph actually looks like. Our first one, we have f of x equals negative x minus 3 times x plus 2 squared times x minus 1 cubed. The first thing I'm going to do is look at my sign out front. We have that negative sign there. That tells us it's a negative polynomial. Then, to figure out if it's even or odd, I'm going to look at every single power of each term and add them together. The first power is 1, the second power is 2, the third power is 3. 1 plus 2 plus 3 is 6, so it is an even function. Since it's negative and even, it's going to look something like this. Now we can actually figure out what's going on in the middle though. So that's our end behavior. Let's figure out what's going on in the middle. I'm going to set each term equal to 0 so I can figure out my solutions. X minus 3 equal to 0 means we have a solution at 3. Since it only had a power of 1, that means we're going to go straight through it. X plus 2 equal to 0 means we have a solution at negative 2. That one has a power of 2, so we're going to have to bounce off of it. Bounce. And then x minus 1 equal to 0 means we have a solution at 1. This one has a power of 3, so we're going to do the squiggle. We're going to do that little flatlining thing. Now we can implement the in behavior and those zeros. Since I need my arrows pointing downward in both directions, I'm going to start with an arrow pointing down. Then I'm going to, since I circled it, it has a power of 2, I'm going to bounce off of the first root, which means I'm going to start going up and then come back down. Then I eventually need to make my way back up to go through, to squiggle through the next one. So I'm going to flatline and then keep going up. Then I know I need to go through the last one, and I have my arrow pointing down, which is exactly what I expected with this in behavior. We don't really care about the turning point when you make your way back to the root right now. We just care about what's happening at those roots and with the in behavior. It could get really, really low and then come back up to 1, or it could be really shallow. We're not worried about that right now. We're just worried about the zeros and the in behavior. Now we have f of x equals x times x plus 4 times x plus 2 squared times x minus 2. I'm going to look at my powers. 1 plus 1 is 2, plus 2 is 4, plus 1 is 5, so this one's odd. And I don't have that negative out front, this guy is positive. So since it's odd and positive, the odd says the arrows are going in opposite directions, the positive says bottom left to top right. Now I can set each of my factors equal to 0. The first one is at x equals 0. That one's going to go through because it has a power of 1. The second one is at x equals negative 4. That's also going to go through because it also has a power of 1. Then we have x equal negative 2. That one's going to bounce because it has a power of 2. So I'm going to circle that one so I remember to bounce off of it. And then x equal to 2, we're going through that one. So this one doesn't have any squiggles. Now from our in behavior, we know we need to start at the bottom left. So going through the first one, make my way back, I need to bounce off of this one, make my way back, I need to go through, and my arrow's going up, which is exactly what I expected.